Hello everyone, hope you all are doing well. We are going to talk about chapter 6. This is one of the chapters that you need to know some definitions and assumption in the chemistry. We need to use this knowledge for solving our problem in the next chapters. One of the concepts in the chemistry we need to discuss about that is the mole. Based on the definition we had for moles, we call one mole like an Avogadro's number. When we say Avogadro's number, we are talking about a number for the first time proposed by an Italian scientist, Avogadro. And this number is 6.022 times 10 to the 23rd number of objects. Objects in the chemistry like atoms and molecules. In our daily life, we deal with some numbers, we call them collection terms, like 1000. When we say 1000 eggs, we are talking about 12 eggs. When we say one case Coke, we are talking about 24 Cokes. So whenever we are talking about one mole, always we are talking about Avogadro's number, 6.022 times 10 to the 23rd number of objects in the chemistry, atoms or molecules. Look at the example here. When we say 1 mole of helium, we are talking about Avogadro's number of helium atom. Whenever we are talking about moles of carbon dioxide, we are talking about Avogadro's number of carbon dioxide molecules. So this number always is a constant and given to you for your midterm, final, and any assignment and quizzes. So you don't need to memorize that. If you memorize that, it will be helpful for you to save your time whenever you are going to solve the problem. So Avogadro's number, it has 4 suffix for our class, 6.022 times 10 to the 23rd number of atoms or molecules. How to apply that information to solve our problem? When we say 1 mole is equal 6.022 times 10 to the 23rd number of atoms and molecules, we are talking about one equivalency, mole and number of atoms and molecules. We convert number of moles to number of atoms and molecules. So we are able to write a conversion factor. So it doesn't matter what is our object. We are able to write like these two forms of conversion factor. It doesn't matter 1 mole on the top, Avogadro's number on the bottom of this fraction, or vice versa. It depends on the problem that we are going to solve. We need to pick one of these two conversion factors. Let me work on one example. I may ask you to read the questions, and after that, for the rest of our presentation, please read the questions and focus on the question. Don't look at the solution. Question says, how many copper atoms are in 0.50 moles of copper? We are going to find relationship between the number of atoms and number of moles. We know one conversion factor, mole and number of atoms. 1 mole like Avogadro's number of atoms. We always start with this original number 0.50 moles, and then we need to write the moles here to cancel it out. So like we reviewed in chapter 2, we write the moles on the bottom and we are looking for number of atoms. Number of atoms should be written on the top. Always we write 1 mole. 1 mole of something. It's same as Avogadro's number of that. Here is copper atoms. If you calculate that, you may find like this number. Again, 2 suffix reported here, we are going to report by 2 suffix. We look at the original number to make sure that we have the same number of suffix. Based on this statement, Avogadro's number converts mole of any substances to number of particles. It doesn't matter, atoms or molecules. Another type of question you may need to know relationship between moles and Avogadro's number and molecules in opposite form. What does that mean? Look at this question. How many moles of carbon dioxide are in this number of molecules carbon dioxide? So we have number of molecules. We are going to find number of moles. So we start with this number, molecules carbon dioxide, and we should write this number on the bottom, because we are going to cancel it out, molecules, and we are going to find the moles on the top. Again, always 1 mole over Here, the number of molecules, Avogadro's number. So molecules and molecules cancel out. If you calculate that, you should be able to get this number. I ask you to calculate that calculation by your calculator. If you cannot get this answer at the end, you should know how to use your calculator. Please stop by in the tutor center or ask me or find out how to use your calculator in the right manner. So it depends on the problem. We may use 1 mole on the top, Avogadro's number on the bottom, or like the previous slide, we may need to have Avogadro's on the number on the top and 1 mole on the bottom. I may ask you to pause this video and solve this problem. This is one of the real chemistry problem. If we are going to find a silver ring atoms, it has like this number. How many moles of silver are in the ring? So you solve that one and check your solution by the final answer. Here we are going to start with this number of silver atoms. So we write that. Again, silver atom should be written on the bottom and mole on the top. Always 1 mole over Avogadro's number. So when you calculate that, you will find like this number. Double check to see if the sig fix is right or not. 2 sig fix are here and we should report by 2 sig fix. So our final answer is 1.8 times 10 to 22nd moles each. Another conversion factor we need to know that this is a molar mass. If we look at the periodic table, we have one box for each symbol, for each element. The number on the top, it was atomic number, we already talked about this. It gives us number of protons and electrons. And for the second number on the bottom, here for this example, for carbon atom, we call it atomic mass. Whenever we are talking about mass, we are talking about grams. So it looks, mass of the carbon atom is 12.01 grams. So whenever we are going to write the conversion factor, we should say 1 mole is same as this mass of the carbon atom. For silver, 1 mole has 107.9 grams. So when we look at any elements in the periodic table, this number represents mass of elements in grams and is equal to 1 mole. So 1 mole of sulfur atom is, it has a mass of 32.07 grams. We call this relationship between mass of 1 mole of atom and mole, we call it molar mass. We abbreviated molar mass by M, and it would be reported in grams, always in grams. So if we say atomic mass of copper, based on the fundamental concept that we had in the chemistry AMU, if we change that one, we may say 1 mole of copper has 63.55 grams. We have different type of reporting, different versions to report molar mass. One of those is gram per mole, or you may say 1 mole is equal to 63.55 grams. I may ask to answer this question. 1 mole of K atoms, potassium. Look at the periodic table, you always have the periodic table, and you should be able to get the correct answer. The number on the bottom of the potassium atom. If you look at your periodic table, you may find like this number, 39.10. If you have the periodic table with more digits, we prefer to have 4 sig fix for our measurement, for our mass. So you may need to run them to 4 sig fix. And whenever we are going to calculate 1 mole of tin atoms, Sn, we may report 118.7 grams. It was for atoms or elements in the periodic table. Assume that we have the compounds. We have a combination of atoms. The only thing you need to know that you just need to add mass of atoms for the compounds and make the molar mass. Look at this example that I'm going to explain for you. We are going to calculate mass of calcium fluoride, CaF2. This is one of the compounds, we call it binary ionic compounds. Whenever you are going to calculate that, you just need to remember that we have 1 calcium and 2 fluorine atoms. Mass of 1 calcium based on the periodic table by 4 sigfigs is 40.08, and mass of fluorine is 19. But we have 2 fluorine atoms, so we multiply it by 2. So whenever you add the numbers, we have 78.08 grams. This is the molar mass of calcium fluoride. For the next chapters, the first step to solve our problem is molar mass calculation. So you need to have enough practice and remember the concept we review for this chapter to calculate the molar mass. So you will have questions like this. Calculate the molar mass of calcium chloride. It would be very similar to the previous example. So you may pause this video and answer this question. If you do that, you may have some solution like this. 1 calcium, mass of calcium is 40.08, chlorine 35.45 multiplied by 2 because we have 2 chlorine. If you add the numbers, we will have like that. Look at the Sigfrid rules we apply. We are going to add these numbers. 2 decimal places, 2 decimal places. Rule for addition. Least number of decimal places or fewest decimal places. 2 decimal places, 2 decimal places, so you should report by 2 decimal places. If your answer is slightly different by this number, 100.97, 100.95, 111.0, we accept that one because it depends on the periodic table that you may use. You may have that one. So I may ask you to pay attention to these examples. I may ask you to work on this, determine the molar mass of K3PO4 for your exam, homework assignment, and also quizzes. You have questions like this one. Determine the molar mass of the name of the compound, not the formula. So from the chapter 5, you need to remember that. What is the formula of the compounds? For this example, the compound is polyatomic ions because we have more than 2 types of elements. We call it potassium phosphate. So if you have questions like this on your homework assignment, determine the molar mass of potassium phosphate, it would be same like that. I'm going to calculate this one. 3 potassium, 1 phosphorus, and 4 oxygen. So you need to calculate, multiply the numbers for each element and add the numbers. Here, if you are going to do that, I'm going to correct this one for you guys. So here 39.10, if we multiply, we should have 2 decimal places. 2 decimal places for the next one, 2 decimal places for the last one. And right now, we should report our final answer like this one. So as you see here, right now we have a correct one. If you use 39.10 times 3, your calculator gives you 117.3. Is not the correct one. You need to report by proper decimal places. If we are going to know what does that mean, 1 mole of the any elements and compounds, if we are going to compare the size, we may have like this: 1 mole sulfur 32 grams, 1 mole Fe 56, 1 mole NaCl 58 grams, 1 mole potassium dichromate. As you see, we need to calculate that. It's too much. And 1 mole sugar, as you see here, is the largest amount of this series of examples. So it depends on the problem, it depends on the compound. Whenever you calculate 1 mole, you may find a number in grams. Questions like this: how many moles of lead does 15 grams of lead represent? So we have mass 15 grams and we are going to convert to moles. So relationship between mass and mole, we call it molar mass. When we are going to solve the problem, the solution, we need to convert grams of this substance to moles of that substance. Look here, 2 conversion factor. If we are going to pick the conversion factor based on the definition we have, based on the problem, we should start with 15 grams. We say 15 grams PB, we need to write grams PB on the bottom and mole on the top. Always 1 mole, we should write molar mass of lead. As you see here, we can cancel out the grams and we report by proper suffix. 3 suffix here reported for pp. So there are some examples on your textbook that you may find. I may ask you to pause your video and answer this question. If you do that, you will see it says how many moles when we have 57.8 grams sulfur. So we start with 57.8 grams sulfur. We should write grams on the bottom and mole on the top. Always 1 mole, and we need to find out mass of sulfur. We call it molar mass. Based on the periodic table that you have, you will find this number. If you calculate this by proper suffix, you should report that one by 1.80 moles of sulfur atoms. We have another type of question, relationship between moles and mass. I may ask you to answer this question as well. We start with 1.05 moles and we need to convert to grams. So the conversion factor we need to have is moles should be written on the bottom. We start with that one, moles on the bottom, and the number of mass of silver should be written on the top. If we do that, moles and moles cancel out and we get the final answer by 3 suffix because we have 3 suffix as well. I may ask you to work on this example. This is another example. You need to know how to use the molar mass to get the answer of this type of question. What is the mass of 3.45 moles of lithium oxide? We need to convert moles to mass. First, we need to calculate molar mass because this is a compound. 2 lithium, 4 suffix for that, and mass of oxygen, 4 suffix for that. If you add the numbers, you may find like this. 2 decimal places, 3 decimal places. You report by 2 decimal places. In row, we start with that number, 3.45. We write that one. Then we should write the moles on the bottom because we are going to cancel it out, and grams on the top. Molar mass of lithium oxide. If you do that, you will find like this number. Again, 3 suffix, 3 suffix. Another possible conversion factor you need to know is combination of definition for mass, molar mass, Avogadro's number, and moles. Look at this number. Question says how many gold atoms are contained in 16 grams of gold. We have this relationship between moles and molar mass, moles and Avogadro's number. See how to apply that one. If we have grams, first we need to convert to moles and then convert moles to atoms. See how to do that. We start with 16 grams. Grams should be written on the bottom, and on the top we should write 1 mole. Grams and grams cancel out. So we have right now moles. But question says how many atoms? How many gold atoms? Right now we need to convert moles to gold atoms. Moles should be written on the bottom and number of atoms. If you remember that at the beginning of this video I talked about the number of atoms and molecules, we call them Avogadro's number. Avogadro's number on the top. So you should multiply 16.0 by Avogadro's number divided by 197. If you are going to report that, I may ask you to calculate by your calculator and report the proper suffix, 3 suffix at the end. So this is our final answer. I may ask you to work on this real example in the chemistry. How many aluminum atoms are in an aluminum can? If you have a Coke, if you have any soda can with this mass 16.2 grams, we are going to see how many of each element present here. This one is aluminum. Question says how many atoms in 16.2 grams. If we are going to solve that 16.2 grams, we write the grams on the bottom, moles on the top, because we are going to convert grams to moles. This is the only conversion factor we have. And then for the second conversion factor, we are going to convert moles to Avogadro's number. If you calculate, you should find like that number, and at the end, like all problems we use, as always, double check sig figs. 3.62 times 10 to 23rd aluminum atoms is the correct answer for this example. It would be same if we have the molecules. I ask you to pause this video and answer this question as well. Find the mass of this molecule. Do you remember what we call this molecule? This compound is molecule or covalent compound. Non-metal, non-metal. We should use prefixes like mono di. For the first element, we never apply mono. So we say nitrogen dioxide. This is the name of this compound. So if you have questions like this on your exam, find the mass of 4.78 times 10 to 24 nitrogen dioxide molecules, you should be able to answer. I'm going to answer that. We can start with the number of molecules. I abbreviated molecules here to save our time or space of writing. When we have molecules, we should write molecules on the bottom. Number of molecules, it gives us one more. Molecules, atoms, we should write Avogadro's number. So this one and that one cancel out. Right now we have moles and we are going to convert to mass. We call it molar mass. You need to calculate molar mass of NO2. Look at the periodic table and I'm sure you know how to calculate that. The final answer is 365 grams NO2. It was a quick review regarding the conversion factors that we have. And the last concept we need to review for this chapter, I'm going to talk about percent composition. The definition we have for the percent is like this one. Relationship between part and whole of something times 100. We call it percent composition. If we have a compound, if we have a formula, the formula is the whole and the element is the part. So whenever we are going to solve that, we are going to follow relationship between the element and compound. It would be important for us to know the percentage because whenever we are going to do some advanced experiment, we are able to analyze the amount of any element in the compounds. We call it percent composition. Let's see how to do that. I'm going to give you like a new strategy, two-step strategy. I'm sure you remember that one. It would be very easy to memorize. For our compound, always we calculate molar mass. You need to calculate the molar mass. And for element, you need to find out from the periodic table. So from the periodic table and bottom, we should calculate this based on the periodic table. Never forget, you need to multiply by 100 because we call it percent. One thing I may ask you, look at this term, it says total element mass. Whenever we calculate total element mass, it means if we have 2 elements, we need to multiply by 2. If we have 3, we should multiply by 3. If we have 5 oxygen, we should say 5 times oxygen. Let's see what does that mean. Calculate the percent composition of K2S. Calculate the percent composition of K2S. Potassium sulfide. First, we should know this is the whole. We need to find part, 2 parts. One part is potassium, one part is sulfur. So, if we calculate molar mass of potassium sulfide, we will find like this number. Let me correct that one here. So, for all of our calculation, thank you guys. Sorry, let me back. This is 110.30. 4 sig figs, and two decimal places to report because we have addition, we will get that. Percent of potassium, mass of potassium on the top over mass of whole molecule, whole compounds. We have 2 potassium atoms, so we multiply by 2 times 100. If we calculate that, 4 sig figs on the top, 5 sig figs on the bottom, we should report by few sig figs, 4. If we are going to calculate for sulfur, it's same. 1 sulfur, we don't need to multiply by any numbers, divided by this. 4 sig figs should be replaced. If we add the numbers, the number should give us 100%. But if we have a slightly changed 100.01, 99.99%, it's fine because it goes back to our rounding group. I may ask you to calculate percent composition for potassium chromate, K2CrO4. So if you are going to calculate that, you should get like this calculation. First, calculate the molar mass. If we calculate like this, we have like this. Okay, sorry about that. Let me back. Here we have 194.20 grams. For potassium, we have 2 potassium, we multiply by 2 mass of potassium divided by molar mass. We have this percentage for potassium. For chromium, mass of chromium divided by molar mass of this compound whole. So we find like this. And for oxygen, so we multiply by 4. 16 times 4, it gives us 64 divided by this number. We should get this number. This is a quick review regarding the chapter 6. I may ask you to work on your problems, on your homework assignment, question given on your textbook, and ask me if you have any question. Please don't forget, you may stop by the tutor center, visit the tutor.com and ask me if you have any question. Thank you guys for watching this video. Take care.